Hello, today I'm going to discuss the notation of a vector in different coordinate systems. The matrix that represents the change of coordinate system. And my understanding came from this beautiful, clear YouTube video, Con, change of basis matrix, which is very clear, but I had a little trouble remembering it, and so I decided to try and work out a system which was more general, that would expand to more complicated systems of basis vectors. So to begin with, I'm just going to use a two-dimensional demonstration because there's less writing to do. I'm going to assume that I have basis vectors E1, E2, and another set of basis vectors F1 and F2, and I denote E as E1, E2, F as the basis vectors, a set of basis vectors F1 and F2. All right, then A with respect to the E basis system or the E coordinate system is A with respect to E1, E1 plus A with respect to E2, E2. And in the same manner, A with respect to the F coordinate system is A with respect to F1, F1 plus A with respect to F2 times F2. Now, if I express F1 and F2 in terms of the E1 and E2 coordinate system, then what I will get is A with respect to, then I will get A with respect to E is AF1, F1 with respect to E, plus AF2, F2 with respect to E. So that A with respect to E is equal to AF1, AF2 times the row vector F1 with respect to E and F2 with respect to E. And this is the change of basis matrix. So that I can rewrite that as A with respect to E is the vector A with respect to F times the change of basis matrix F with respect to E. Now I can also write that A with respect to F is A with respect to E times E with respect to F, using the same arguments, the same system as I've used before. So A with respect to F is A with respect to E times the change of basis matrix E with respect to F, which is A with respect to E times the matrix F with respect to E to the minus 1, because if I multiply this by F with respect to E to the minus 1 on each side, I get A with respect to F on the right side is equal to A with respect to E, Fe to the minus 1. And that's the system. It's a lot of, it's probably overkill for just two, dimension 2 coordinate system, but it helps you keep track of things when you're looking at a lot of vectors and various coordinate systems. You know, what do you mean by vector A, and what coordinate system you're referring to? This keeps track of everything. Now, there is an alternate notation that you could use. I could say that A with respect to E up here was equal to F1E, F2E, column times AF1, AF2. That just follows from this here. Okay, in which case A with respect to E is F, is the change of basis matrix, F with respect to E, and A sub F, as defined here. You have to be clear on which system you're using, which notation you're using. So this is more standard in this sense. However, this is much easier to read and keep track of things, because this says A with respect to E is A with, you have to read it backwards, it's A with respect to F times F with respect to E. However, this here, the beauty of this system can be seen when you go to a general change of basis. If I have A with respect to G, where G is another basis, that is equal to A with respect to B, which is another basis, times B with respect to F, times F with respect to E, times E with respect to G. A lot of complicated expressions get condensed in a very simple expression if you're talking more than one basis system. Then then I might add that if, for example, as a matter of notation, if I have this arbitrary vector b1, subscript 1, then I would denote that as b1 with respect to f as b1 with respect to f1 plus b1 with respect to f component 2 f2. As I say, I think one of the best reasons for working through the system is to understand the going from one basis system to another. What happens to the vectors? What matrix is involved? How do the matrices change? After that, once you get the understanding, then you probably can just use standard notations. I'll leave it up for 1 second or for a minute, so that if you want to just study it, I'll give you a chance to hit stop and you can look at it and go through it. As I said, if you work your way through it, the main advantage of it is, unless you're dealing with very complicated systems, it's a clear understanding, I hope, of different basis systems and how components interchange between the different basis systems. Thank you. But hold it for 1 second. Okay, let's do that. It's not going to get perfect.